Hello everyone, welcome to IEEE Expert. Today we are going to see one of the medical relevant project only, the project named as blood cancer detection using deep learning. This is not the basic title, we can add some more content with the title which will give more boost in our project title. Okay, earlier blood cancer detection using deep learning, that's what we are going to do. We are not going to predict, we are not going to detect blood cancer or not. Okay, if we are uploading any samples, this project will not detect there is a blood cancer or not. Okay, this will predict the stages in blood cancer. Okay, you are in a pre-stage, you are in a earlier stage, you are in a post stage. It will predict the blood cancer stages in your blood sample. This is what this blood sample detection project we're going to do. Okay, this project comes under deep learning. Okay, first of all we have to know that what is the meaning of blood cancer. Okay, blood cancer means the growth of abnormal cells in your human blood. This is what called as a blood cancer. Okay? If you are having abnormal growth of blood cell in your blood means in future what they will do means it will stop the blood flow. Your blood can't flow frequently, okay, easily. So it will affect the movement of the blood, which will causes more organ failure in future. So that's why we are called as blood cancer is one of the serious disease in our current society. Okay, the last year 2024 itself, the database shows that around 30 lakhs people died by the blood cancer. So that the earlier prevention of the earlier detection of blood cancer is very important for our society. Okay, the major variety of projects available on this particular domain, but more of the project largely depends upon the not prediction, detection only. What they did was, if you are uploading any blood sample images means what they will do means it will detect whether you are having blood cancer or not. Okay, that means leukemia. Okay, the blood cancer also called as a leukemia. It will tell you are having leukemia or not. That's what they will do. But in our project data set, we have collected around 6,500 plus images. We have classified, we are categorized into 4 parts. Okay, there is no blood cancer, stage 1, stage 2, post stage. Like this, we have classified various images in our data set. That's what major advantage of this project. Okay, so based on this data set only, our project going to work. Here we have to apply very lightweight machine learning algorithm, the deep learning algorithm. What's the advantage of lightweight deep learning algorithm compared to the common deep learning algorithm was, so if everyone using handheld devices, laptop, tablets nowadays, you can't expect a high powerful processor, graphics processor in each and every devices. So that we require lightweight algorithm. For that lightweight purpose only, what we are going to do means we are going to apply Mobilenet version 2. Okay, Mobilenet algorithm we are going to apply for the classification, that means training as well as testing purpose. Okay, also we are going to use web application, the user friendly web application, where the user can easily upload their blood sample. Based on the blood sample, it will predict whether you are having blood cancer or not, what stages you are in. You are in first stage, second stage or third stage. Okay, it will give the results based on that. So this is a very user friendly application. Anyone can use this application for their blood cancer prediction purpose. Okay, also here we are taking microscopic images only. We are not going for the biopsy images or a pathology images. We are using normal microscopic images only. Like that, you can take your blood drops, you can put it on a microscopic laser. It can give the microscopic images of your blood. Directly put the images on our project, you can get the results. Okay, also this project will work for the any blood group. Okay, if even you are having a rare blood group also, this project will work perfectly. Okay, that is the major advantage, vast advantage of this project. Also, one more thing I have to point out here, this project completely uses a web application, which will be very useful. And one more thing, this project targeted to achieve higher accuracy when compared to the previous models. Okay, the Mobilenet version 2 which we are using able to produce, okay, it's achieved already 98.6% accuracy, relevantly 99%, which is huge for the current standard. We are using lightweight algorithm here, but it achieved 99% relevantly. Okay, you can compare the results. Okay, also you are using around 6,500 plus data sets. Okay, now you can know the worthable of this project. Okay, this project built on the Flask platform, which can able to build a web application. Here we are using Python for the backend. For front-end part we are using as well as HTML, CSS, JavaScript for the front-end part. Okay, to know about the this project more, connect with this video. We are going to produce complete presentation of this project. We are going to explain the demo of the project and everything. Please connect with this video. This is one of the very interesting as well as useful project for engineering as well as medical society. Thank you. So I can explain the project presentation for you. So before explaining the project presentation, I can move the project base paper. This is the project base paper which you are going to consider for this project. This project base paper published on IEEE, which is 2024 year. The project titled as Leukemia Cancer Detection in Microscopic Blood Sample Using Optimized Convolutional Neural Network. So this is the title they have used for that project. That means the existing system. Here you can get to know that leukemia detection. So what's the meaning of leukemia means? Basically for blood cancer, they are called as a medical term as a leukemia. So leukemia refer to the medical term for the blood cancer. So originally they are predicting blood cancer detection only here. So they have used convolutional neural network. Optimized convolutional neural network means they have reduced the overall layers depends upon their data set. Okay. So this is the project which you are going to which is the base paper which you are going to refer for this project. So you can see this is the microscopic images of the each and every blood samples. Okay, they have applied some data augmentation also for increasing the data set size. This is the overall accuracy they are going to achieve. So you can get to know that this project, the existing system achieves 97% accuracy overall, but we are going to achieve 98.6% accuracy. So which is higher than the existing system. Okay, in this project they have used convolutional neural network now. So instead of that convolutional neural network, we are going to apply Mobilenet version 2 algorithm. This is what we are going to do. So let me move on to the project presentation explanation. So this is the project base paper which you are going to explain. So our title belongs to a deep learning based approach blood cancer detection using Mobilenet algorithm. So this is the project title here. So in the abstract, you can mention that you can refer that blood cancer is one of the life-threatening disease for the overall society. So the survival rate for this blood cancer is very low when compared to the other things. So we have to implement an algorithm to detect this blood cancer in an earlier stage itself. So what are the disease? Whatever disease you are predicting as much as earlier means the chances of curing this diseases was high when compared to the last stage of disease. So it is very important to predict these diseases in earlier stages. So that's what we are going to do. We are going to predict this breast cancer in an earlier stage itself. That's what we are going to do. Here we are going to apply some additional steps as a image enhancement, noise reduction. These are some additional pre-processing steps we have to achieve in this project to get the better accuracy. Blood cancer. First of all, you have to know that what is the meaning of blood cancer. Blood cancer means usually the blood cell, okay, the blood cell which is present on the blood flow, okay, these cells will grow continuously, okay, without any control. These blood cells grow continually. Once certain period of time, after certain period of time, what will happen means these cells grow continuously, so which will stop our blood flow, okay, which will stop our blood flow. The blood can't absorbed by the organs, human organs. So without blood, these organs will failure one by one. So that is the major life-threatening disease here. Blood cancer, the chance of survival in blood cancer is usually low. Why? Because it will affect all our organs. That is the main issue here. Okay. So we have to predict this blood cancer as much as earlier as possible. Okay. So introduction, we have created a deep learning model which is more accurate as well as efficient, which will work on any algorithm. Here we are using CNN based Mobilenet algorithm, which is lightweight, can run on any system. That's what we are going to do here. So literature survey, we have to present some recent literature survey. We have taken around 5 papers for this recent literature survey. So all are recent papers only. You can see mostly they are using SVM based algorithm or old CNN based algorithm. This is what they are using. Here you can find the accuracy. The accuracy is very low when compared to our proposed system. Okay. This is the overall literature survey for this project. This is the existing system. Usually in existing system, the doctor will conduct a pathologist testing. He will take the blood test, okay, by using microscopic. He will reproduce his own data, okay. He will reproduce his own analysis. What the main drawback means, it will take too much of time as well as it will produce false result also. An automated system, basically in exiting system, some person able to build cancer classification. If you are uploading any blood sample means, what they will do means, this system, the automatic system will predict whether you're having blood cancer or not. That's what they are going to do. But the major drawback here was this automated system using conversion neural network, which will require GPU, graphical processor unit. Okay, so it won't work with a normal system. That is the major drawback here. So for this drawback only, we are going for the proposed system. So when compared to the existing system drawback, subjectivity. If you are going with a manual process with the doctor analysis means, there is a chances of human errors there. So higher cost. Okay, so if you are going for the biopsy test as well as diagnostic tool means, it will take huge amount of cost to predict. Okay. So then expert dependency. The doctor need high-end skill to predict that blood cancer and all. Okay, normal usual doctor won't express in these things. So computational complexity. If you are going for the automated system like CNN and all means, you need huge power, computational power, GPU, graphics processor, high-end CPU like that. So this is the major drawback. To overcome all these issues in the existing system, we are going for the single and proposed system, which is our proposed system. So moving on to our proposed system. This is our proposed system. Our proposed system mainly aim to enhance the overall accuracy of the existing system using a Mobilenet algorithm. Okay, Mobilenet is a suboptimal process of the lightweight convolutional neural network. Unlike traditional CNN model, this system uses largely low intensive task, largely low resources. Okay, but it will produce higher number of accuracy when compared to the traditional system. That is the major advantages here. So in this system, blood smear images means, that means a microscopic images, okay, taken, then pre-processed using some algorithms. Then what we are going to do means, we have to extract the features from the each and every blood sample, which is called as a feature extraction, which will conducted by the Mobilenet algorithm, as well as then we are going to improve the overall training accuracy as well as same Mobilenet version 2 algorithm. Here we are going to apply some data augmentation also to increase the overall accuracy of the data set. So using this proposed model, we are getting higher accuracy, precision, recall and F1 score values. So this is the overall proposed system. Architecture of the project is given here. So you have to take blood sample images, then you have to apply pre-processing. In the pre-processing step, what you have to do means, you have to do some noise cancellation, noise minimization and all. Then using the feature extraction, you have to extract the important feature of the each and every blood sample. Those features only going to train as well as test for the overall disease classification. Then this feature extraction step passed to the classification, which means a training. So in the training stage, we are building the custom Mobilenet model. What the custom Mobilenet model will do means, it will train all the data features which is obtained from the dataset. So as we mentioned earlier, this project uses around 6,500 dataset. Those data are trained under the Mobilenet model. After training all this data, we are going to store that data into the pre-trained model. This is a H5 file which will store all the features, pre-trained file. That pre-trained file only overall brain of the system. Okay, by using that pre-trained file itself, you can able to run the project without training again. Okay, having all the stored data. Then what we are going to do means, we are going for the testing stage. In the testing stage, keeping the user in mind, what we have to do means, we have to build a web application for the easier access of the common audience. This common audience can be able to log in with their details. Usually we are using admin as a username password here. They can use their login. Using that login, what they can do means, they can upload their blood sample, which is a microscopic images sample. They can upload. Our system will test that images, compare with the pre-trained values. It will extract the feature extraction again. For the test images, it will extract the feature extraction. Those features already compared with the trained data set. Based on the comparison, which will produce the results. Okay, you are having stage 1, stage 2, stage 3 like that. So what you have to do, what is the major drawback, everything it will explain. So this is the overall architecture of the project. Hope you understand this thing. So this is the modules. So as I mentioned earlier, we are comparing this project as a 4 modules: dataset collection module, data pre-processing module, training module and evaluation, that means testing module. This is the overall modules of the project. So comparison, we have to explain the overall comparison of the project. This is more important, okay? When comparing to the base paper, what you have did. So usually in the data set, in the base paper, they have used all IDP data set, okay? But here we are using leukemia all images data set. So that's a major difference. In exiting, you are getting 97% accuracy, but in our proposed system, you are going to get 98.6% accuracy. So that is the enhancement we did. Base paper used to CNN, traditional CNN model. We are using lightweight Mobilenet version 2 model. GPU requirement. Surely this existing base paper need graphics processor to run the operation, but our proposed system is a lightweight model. You don't need any graphics processor, okay? Without graphics processor itself, basic CPU can run this project, okay? That's the major advantage. So sequence diagram is given here, use case diagram is given here, as well as activity diagram also given here. You can find the class diagram. All the diagrams are given for this project. Let me move on to the hardware requirements. To run this project, you need minimum i3 processor, okay, 10th generation. Then you need a hard disk of around 20 GB space on your C drive, okay. So for this project, you need 4 GB of RAM minimum. You can run this project with Windows or iOS, whatever. Language you are using Python, HTML, CSS, JavaScript for the overall end web application. Okay, this is a Flask based framework for the web application. Major advantages was this is a real-time detection. You can upload whatever images, whatever blood images, you can get the results, as well as more accurate. You can improve this model with anything, okay, mobile phone and everything. You can improve your own customizations. Conclusion. In the conclusion, we have mentioned that the blood cancer is usually predicted with the Mobilenet algorithm, which is more accurate as well as scalable. This is a lightweight algorithm, so it can produce the results in a faster manner. In conclusion, we have mentioned this deep learning model is very much useful for the potential revolution in the medical field, okay, which is cost effective as well as more accurate when it comes to the diagnostic. That's what we are going to do, okay. So this is the reference for this project, okay. Thank you. Please connect with this video. Let me move on to the project demo, okay. Thank you. So before running this project, I can show the data set for this project. So this is the data set which you are going to use. Here you can see this is the original data set. You can find winning, earlier, pre-pro. So this is the 4 steps we are going to use, 4 type of classification we are going to refer. So this is the overall images, okay. This is the images which we refer to the white blood cell, okay, earlier, pre, then pro. This will look like a same images only, but our project will distinguish all these things. So I can go to the code of this project. So this is the project code we are going to use. Here if you are going for the templates, means you can find the HTML code for this. So this is the main code, app.py. This is our main code of the project. So this is the Python code which you are going to use. So here notebook available for the training purpose. You can find the training code here. So this is the training code, okay, Mobilenet algorithm training code. You can find the accuracy. So this is the overall Mobilenet model which you are going to use. So you can find the overall accuracy for this project. You got around 98.6 accuracy on training. For validation, you are getting 99%, 99.2% for validation. So this is the accuracy you are getting. So this is the graphs for that, okay. So without wasting my time, I'm going to run the web application for this project. So to run the web application, you have to copy the link of the project. So after copying the link, go to the Anaconda Navigator. So this installation instruction can be provided along with the project. In Anaconda Navigator, I am opening the required terminal for this project in the particular environment. So once you open the terminal, what I am going to use means I am going to type cd, change directory, cd space link of the project. Okay, once I am pasting this, I have to run the main code. So this is the project main code, app.py. So what I have to do means I have to type python space app.py. This is what I am going to write. So once I am typed python space app.py means it will give the web application link. Okay, it will run the code. If there is any error means it will show the error, or else it will give the overall website link. So this is the link. After copy the link, what I am going to do means I am going to paste on the private window. Okay, just pasting the link, that's enough. Once I pasted means it will give the website. So this is our project website. You can see predicting stages in blood cancer. Okay, this is what we are going to do. A based This is type prediction. Okay, so this is the home page. In the home page we are given complete details, so you can predict the disease stage as well as you can get the accurate results. So you can get around 98.6% accuracy. So we are using latest technologies in this project. So we are taken around 6500 images for training. There is a 4 type of classification is there. Overall accuracy 98.6. For running this project we are used to around 70 number of training approaches. Okay, so this is the thing. The overall models involved in the project was dataset collection, pre-processing, feature extraction, custom training, then web application. So this is the models involved in this project. Okay, so why this project means, so this project uses modern technology. This is future proof. You can update for anything. This project completely based on the award targeted function. Okay, for medical emergency. So this is the features available in this project. This is the footer page. Okay, these all implemented using the HTML things. So you can find the services pages also. In services pages also this data is given. So you can move to the about a section. About a section also these data are available. So student name, you can use the student name here. Okay, your name after purchasing you can use your name here. So to check the things I'm going to use login. Inside the login I have to use admin as a username password. I have to use admin as a username password for this project. Once type the admin means it is giving the login success. Once login success means, so this is the home page for the, this is checking, this is prediction. So welcome to the blood cancer detection. This is the advanced blood cancer detection project. You can upload any things to check you are having leukemia or not. Okay, this is what you are going to do. Okay, this is completely a earlier diagnosis. You can predict the disease in an earlier stage itself. That's what the major advantages we have did with this project. So here you can upload and check any images. Go to the choose file. So what I'm going to do means I'm going to choose any images for this project. So I'm going to choose the images folder. So blood cancer detection. So here I used text images. There is a text images. I have pasted some random text images here. Just selecting any random images. Okay, just detect stage. That's enough. So once detected stage is there means what you have to do, just go to the results. The results generated by the microscopic blood smear images. You are used to mobile network version 2 algorithm here. Okay, you can check the results. So you are having pro B. So this is the diagnosed stages for that images. Blood sample pro B. You don't know what's the meaning of pro B means. Go to here. So you are getting pro B. Pro B is a stage 4. Okay, this is a stage 4, commonly stage 4. This is the last stages of the blood cancer disease. Okay, now what I'm going to do means I'm going to upload one more images here. So go to here, I'm going to upload any other random images. Okay, so random images I'm uploading. So after predicting I'm going to check the results. You are having pre-B. This is your stage. So what's the meaning of pre-B means? So acute lymphotic leukemia. So lymphocytic leukemia. This is your earliest stage. So you are in the first stage. Okay, in the first stage there is some treatments are there, the post remission therapy as well as maintenance therapy. These are the therapies available for this stage. In using this therapy there is a chance to overcome this disease, blood cancer disease. Okay, that's the most important for this project. You are predicting the disease in an earlier stage itself. Okay, pre-B. So you are getting disease as a pre-B. So you can see pre-B. So I'm uploading one more images for the testing. So I'm going to check here any other images. So now I'm going to use this thing. Just click detect stage. So I got the results. Go to the results. You are having pro B. So pro B again is a last stage. You are having in a last stage. So any other images I'm going to use. So go to here. I'm going to upload any other images. This time I'm going to use this image. Just detect stage. So pre-B, you are getting disease stage as a pre-B. So pre-B means, so you are in a third stage. Okay, this stage called as a chronic myeloid leukemia. This is the stage 3. There's a chances of cure is there, but very rare stage. Okay, there is a very rare chances of survival. Okay, this is a stage 3. Okay, I'm going to upload one more images here. So one more stage. I'm using this images this time. So I got a result as a benign. Okay, benign means there is no relevant data for the blood cancer. The targeted blood cell look healthy, so you don't have any blood cancer. Okay, this is the stage, 4 stages involved in this project, so it's perfectly working. Okay, you can upload whatever images and you can check. Okay, whatever blood image, you can't upload any third party random images like car image, bike image. This project completely trained for the 4 classes only. Some guys are doing that, they are uploading random bike image, car image, they are asking why it's showing like this. Okay, this is not the object detection project, this is specifically trained for the 4 classification only. Okay, even you are uploading blood images, it will give the results. Okay, you can't upload the random image. These are the basic things in the deep learning. Hope you should understand the things. Okay, go for the accuracy. You can check the overall accuracy of this project. So as I mentioned earlier, you are getting 98.6% accuracy. The loss rate of training loss is also 0.3% only, which is very low. This is the confusion matrix for this project, overall confusion matrix. This is the architecture of the project. Okay, this project completely built using web application using a Flask. It's perfectly working. Okay, to get this project, what you have to do means you have to contact ieexpert.com. If you are contacting ieexpert.com means we are giving this project as best price. Okay, so this is our website ieexpert.com. You can contact this website for getting this project. There is plenty of machine learning, deep learning projects available here. You can check all the things here, abstract, base paper, everything given with video. You can check all the projects and purchase the project if you really need this project. Thank you.